Hi, now we are going to discuss a new topic, overlap save method. Let us go through a problem. Find the output y of n of a filter whose impulse response h of n is equal to 1 comma 1 comma 1 and input signal x of n is equal to this signal using overlap save method. Okay, now let us solve this problem. Here the input is x of n, impulse response h of n, and output of the system is y of n. So let us draw the schematic of this question. This is our system, okay, whose impulse response is h of n, and input to the system is x of n, and corresponding output is equal to y of n. Okay, now let us take the length of the impulse response. That let it be m. Here m is equal to what is the length of impulse response h of n? That is 1, 2, 3. Is equal to 3. Next, we are going to divide x of n into some blocks of data such as x1 of n, x2 of n, etc. Okay, let us take the number of data points. L is equal to 3. Okay, 3 data points. Now let us take 3 data points from the given x of n and let us construct x1 of n. In order to construct the discrete data block x1 of n, first of all we have to add, or we have to put m minus 1 zeros. Here m is equal to 3, so m minus 1 gives 3 minus 1 is equal to 2. So we have to put 2 zeros while constructing the first block x1 of n. Okay, we don't need to do the same in the preceding sections. We have to take the first 3 elements. Okay, 3 minus 1 0. Okay, this step is over. This is m minus 1 is equal to 2 zeros, and these are L is equal to 3 data points. Okay, so in order to construct x2 of n, we have to use the last m minus 1. M minus 1 means 2. Last 2 points that is to be taken from the previous block. These are last 2 points, minus 1, 0. Next, these are last 2 datas. 2 datas from 2 in the sense of minus 1. Okay, from previous block. Okay, right. Next, again the data points is equal to 3, what we set. So we have to take the next 3 data from the given x of n. Next 3 data means these 1, 3 and 2. 1, 3 and 2. Okay, these are next 3 new data points. Next 3 data points. Then construct x3 of n such that you have to again reuse the last m minus 1. M minus 1 means last 2 data from previous block. This is the last 2 data, 3 and 2. Then we have to take another 3 new data points from the given x of n. Okay, these are 0, 1, 2. 0, 1, 2. These are m minus 1 data from previous block. Okay, these are 3 new data points. Okay, right. Then again, one element is remaining here, so we have to construct one more data block x4 of n as in the same manner. Reuse the last 2 datas from the previous block, 1 comma 2, last 2 datas. Next, put next 3 elements. Here we have only 1 element. Okay, so in order to make the data length equal with x3 of n, x2 of n and x1 of n, we have to put how many zeros? We have to put, here we have 3 datas. In order to make the length of each blocks same, we have to put 2 more zeros. Okay, right. Now it's over. The data block making procedure is over. Next we have to take the circular convolution. Before that, it's given that x of n, that is the impulse response given, that is equal to 1 1 1. To perform the circular convolution, both h of n and these discrete blocks should be of same length. So I'm going to put how many zeros? This is the data length should be 5. Here we have only 3 elements, so we have to put additional 2 zeros. Okay, now the length of h of n becomes 5, which is exactly same as that of x of n, x2 of n, x1 of n and x4 of n. Okay, next we have to find out y1 of n, that is equal to x1 of n circular convolution h of n. You have to find the circular convolution between h of n and the first block x1 of n. Okay, that is the output y1 of n. The details about the steps means how to perform circular convolution, that is explained in my previous videos, and the corresponding link will be available here, and also the link will be available in the description box below. We can find the circular convolution either using concentric circle method or using matrix multiplication method, whichever it may be. Now I'm going to write the final result of the circular convolution. The details of performing circular convolution is available in my previous video. Okay, next we have to find y2 of n, that will be of course the convolution between the second block element x2 of n with h of n. x2 of n circular convolution h of n. Again, the details of the steps that is not going to given here. Anyway, you can find out by any means, either using circular convolution or matrix multiplication method. I am going to write the result after this one, that is equal to 4 1 0 4 6. That is the result of y2. Next, I have to find y3 of n, which is the circular convolution between x3 of n and h of n. Again, the answer is equal to 6 7 5 3 3. Okay, right. Finally, we have to find y4 of n, which will be equal to x4 of n circular convolution h of n. that is 1 3 4 3 1. Okay, right. In order to understand very much easily, I'm going to write the results of circular convolution one by one, one after another. Okay. Okay, these are the results what we obtained after performing circular convolution. Next, we have to write y of n, I mean the final output from y1 of n, y2 of n, y3 of n, and y4 of n. For that purpose, we have to discard first m minus 1 elements from y1 of n. M in the sense m equal to 3. Okay. 3 minus 1 means 2. So let us discard first two elements from y1 of n and write the remaining elements only. That means 3, 2 and 2. 3, comma 2, comma 2. Next, from y2 of n also, let us discard two elements, first two elements, and the remaining can be taken in order to construct y of n. The remaining elements are 0, 4 and 6. 0, 4 and 6. Again, from y3 of n also, discard first two elements and take next data 5, 3, 3, and finally let us take the last three data after discarding the first two one. Just discard first two elements from y4 also and take the remaining data, means 4, 3 and 1. Okay, 4, 3, comma 1, and that will be the result of our problem. I mean that will be the result of the system or the output of system y of n for the given signal x of n and impulse response h of n. Thank you.